Hello again, everyone. Let's get out, if you haven't already, lesson 17, modeling with inequalities. Let's look at solutions to inequalities is what the test is today in a nutshell. We'll start with a warm-up. It's a good problem. The stage manager of the school musical is trying to figure out how many sandwiches he can order with the $83 he collected from the cast and crew. Sandwiches cost $5.99 each. So he lets X represent the number of sandwiches he will order and writes $5.99. X is less than or equal to 83. That's a very good equation. Fair enough. He solves it to do decimal places. Getting X is less than or equal to $13.86. That's correct. Everything looks good so far. So which of these are valid statements about the situation? Select all that apply. He can call the sandwich shop and order exactly 13.86 sandwiches. Circle that one if you think that's correct. He can round up and order 14 sandwiches. He can order 12. He can order 9.5. He can order 2. He can order -4 sandwiches. So, which ones of those do you think are correct? If you think he can order, and if you've ever seen anyone order 13.86 or 2.86 or 5.86, please send me an email right now and tell me about that story, because that would be weird. I don't think that's ever happened. So number one doesn't make sense. He can round up and order 14 sandwiches. Not according to this situation. Yes, if he had some extra money, but he doesn't. He has $83. So technically, he can't round up. He can round down and get 13 sandwiches. Maybe some places sell half sandwiches, but usually they're for, not quite, they're for more than half the cost. But in this case, 14 sandwiches is not possible. He can order 12 sandwiches. Well, yes, he can order anything less than 13.86, so 12 works. 9.5, like I said, it works if they sell half sandwiches. In some places, you can get a 6-inch instead of a 12-inch or something like that. He can order 2 sandwiches. Yes, I wouldn't recommend that. He's got to get, but he technically could. He can order -4. Well, any number that's less than 13.86 technically works. Except, again, this is saying now that we solved our answer, there's actual meaning to our answer. So technically -4 is less than 13.86, and it is a solution to that inequality, but not in this context. So we should probably circle 2, 3, 4, and 5. Again, 4 has an asterisk, depending on the place sells half sandwiches, which most places do, maybe. I don't know. Now, great problem here. 17.2 elevator. A mover is loading an elevator with many identical 48-pound boxes. The mover weighs 185 pounds. That's almost exactly what I weigh. The elevator can carry at most 2,000 pounds. Write an inequality that says that the mover will not overload the elevator on a particular ride. Check your inequality with a partner. So, if you were to write an equation, you're going to have to, like this, right here is an inequality. You're going to want a little more than that. What are you going to write? What would you write? Go ahead and try writing it lightly in pencil. If you get it wrong, we'll cross it off. I would say we've got 185 pounds. We're going to have the mover. Plus, we got to do boxes. They're 48 pounds. So plus 48 pounds times however many, we can call it B for boxes or X for boxes, whatever you want. Whatever letter you want. That's got to be less than And it says at most, meaning it sounds like 2,000 pounds will work, but that's got to be less than or equal to 2,000. Now, if you remember to solve this, we can just pretend it's an equal sign, right? If we want to, we can just pretend that this is an equal sign. But I'm not going to for now, so that we can at least remember that it's less than or equal to. So the weight of the mover plus however many boxes, we don't know how many, as long as that's less than or equal to 2,000 pounds, the elevator should just be fine. Wouldn't want to test it. So what would you think step one would be if we got to figure out how many boxes, even though it doesn't tell us that that's the question, but it is just saying, hey, let's not overload it. What would we have to do to figure out how many boxes? I think a lot of you are saying, hey, let's get rid of the person 185 pounds. 185 minus 185 is nothing. 2,000 minus 185, on the other hand, less than or equal to, is going to be 1,815, maybe? Hope that's right. 0, 5, 1, borrow, boom, boom, boom. That sounds about right. 185 plus that. So we've got 1,815 pounds left that we can distribute among 48-pound boxes. So what do we do now? 48-pound boxes. How many can we do for 1,815? What should we do here? If you said divide each side by 48, you would be correct. So that is going to look, I'm going to divide this side by 48. I'm going to divide this side by 48. Guess what? 48 divided by 48 is 1. 1b, or better yet, the number of boxes we can do. The boxes is going to be less than or equal to, if I do that on a calculator, I'm going to get 37.8125. So that's kind of our answer. We could leave it like that, but again, we have to explain what our solution means. So we can have 37.8 boxes. Does that make sense? Let's make it make more sense. Technically, this should be B is less than. So does that mean we could have 38 boxes? If we do that, I think you'll agree that will make us go over 2,000 pounds. So we probably got to cut it short and leave it right at the 37. That will leave us below or at the 2,000. It'll leave us slightly below, but to do it exact, that means we have a fraction of a box, and that's just not going to happen. So it says, explain what this means. It means we can have up to 37 boxes. It's not like we have to. In fact, I don't think 37 boxes, unless maybe they're watch boxes or something, depending on what size, but 48-pound boxes, who knows? I wonder what's holding 48 pounds. But nevertheless, 37 of them. We can have up to 30. We don't have to, but up to 30. It says graph your solution on a number line. So here's our number line. I'm going to go right here and call that 37. And we can have anything less than or equal to, we'll give it a solid dot because we can have up to 37. And we're going to need to draw an arrow anything less than 37. And that's all we technically need to do. If the mover asks, how many boxes can I load on this elevator at a time, what would you tell them? 37. So kind of by asking what the solution means, we kind of answered number 4. So guess what? There is 17.3. There are some problem cards and some data cards. And those are good problems to do, but I'm going ahead and, since it's the weekend, we're going to be the weekend, we're going to go ahead and cut this lesson short. With that being said, we're going to jump right into lesson 17, practice problems. So pause this video if you need to, but go ahead and go to your lesson 17 practice problems. Let's get them all done, and then you'll go home with no homework. And hopefully you're there and you're ready to rock, because here we go. Maybe I might jump. I think I have this set up for some blank pages. Almost. Because I think I'm going to need some space. You might even need some scratch paper, in which case you can go grab some if you think you're going to need. If you think you can write small enough, then fair enough. But there's a lot of work going to be needed for all these problems. If you look down at number 3, not enough space to solve those, but not a big deal. Number 1, 28 students travel on a field trip. They bring a van that can seat 12 students. Elena and Kieran's teacher asked parents to drive cars that seat 3 children each to transport the rest of the students. Let me read that again. 28 students. They bring a van, takes 12 students. Elena and Kieran's teacher asked parents to drive cars that seat 3 children. Elena wonders if she should use the inequality 12 plus 3n is greater than 28, or 12 plus 3n is greater than or equal to 28 to figure out how many cars are needed. Kieran doesn't think it matters in this case. Do you agree with Kieran? Explain your reasoning. 12 kids that sits in one van plus 3 kids times however many vehicles we need has to be greater than 28, or 12 plus 3n is greater than or equal to 28. Do you figure out? She doesn't think it matters. Do you agree with Karen? Explain your reason. What do you guys think? Do you think it matters? Do you agree with Karen? What are you guys thinking? I think if we were to solve this, maybe she's saying it doesn't matter because let's go ahead and quickly solve it. Because maybe by solving it, 12 plus 3n is greater than 28. First step is subtract 12, subtract 12, subtract 12. 28 minus 12 is 16. You don't necessarily have to write this if you didn't want to, but it doesn't hurt to practice and get in the habit. Divide each side by then. If we get rid of the 12 kids or the vans, that means there's 16 kids left for vehicles. 12 are in the van, that means 16 are left that need vehicles, and there's 3 in a vehicle. So how many vehicles? Well, 16 divided by 3, that means n has got to be greater. The number of vehicles has to be greater than 16 divided by 3. 3 goes into 16. 5 with a remainder of a third. So maybe Kieran is saying it doesn't matter because she knows if n has to be greater than 5 and a third, saying that it's equal to 5 and a third isn't going to matter because no matter what, we need 6 cars. So whether you say it's greater than or equal to, no matter what, we have to round up. So maybe that's what Kieran is thinking, saying, well, wait a second, if we're going to need 6 cars regardless, what difference does it make if it's greater than or equal to? So go ahead and put that into words however you think is best going to fit your brain. But interesting nonetheless. Hit the pause if you need another minute or two to write this down. But they need 5 1/3 cars, obviously. In other words, they need 5 cars. If 3 people took 5 cars, that's 15 kids, and then 1 kid would fit in 1 car. Granted, maybe 2 cars would split up and 2 kids would go in each, but that's neither here nor there. All right. Number 2. In the cafeteria, there is 1 large 10-seat table with many smaller 4-seat tables. There are enough tables to fit 200 students. Write an inequality whose solution is the possible number of 4-seat tables in the cafeteria. There's 1 large 10-seat table, so there's nothing we can do with that other than call it 10. And many smaller 4-seat tables, plus 4 times however many. I would use T, but T's sometimes look like plus signs, but let's go ahead and plus 4 times however many smaller tables. There's enough tables to fit 200 students. So that should be all those. That can't necessarily be greater than 200 students. I believe all of that should fit 200 students or less, because it's not like you have to have it be exactly 200. There's not always 200 kids going to be eating there, but it could hold up to 200. So all those tables hold up to 200 or, of course, less. So it says, write an inequality whose solution is the possible number of 4-seat tables in the cafeteria. If we were to solve that, we would just do 200 minus 10. That'd be 190. And take 190 and divide it by 4, and we would get the number of tables. But it just says write an inequality. It doesn't even say to solve it, so don't mind if I don't. 5 barrels catch rainwater in the schoolyard. 4 barrels are the same size, and the 5th holds 10 liters of water. Combined, the 5 barrels can hold at least 200 liters of water, at least. Write an inequality whose solution is the possible size of the 4 barrels, at least. That's weirdly worded. So it means they can possibly hold more than that. So this is kind of similar to the last one. Oh, question C says, how are these 2 problems similar? How are they different? I've got 10 liters in the 5th barrel, and there are 4 that we don't know how much they hold, plus 4 I don't know, I won't use B for barrels, but technically I think it should be L for liters. 4 times however many liters. I'm going to use a cursive L. And that needs to be, it says it can hold at least 200 liters. So technically this is at least means it can hold 200 liters or more. Which is kind of weird. And then the question says, write an inequality. Oh, good, we don't have to solve it. Even though, guess what? We're going to get the same answer as A. Now look at the equation for A and look at the equation for B. It says, how are these similar? How are they different? Go ahead and you can look at that and come up to your own conclusion. Hit pause on the video, and when you're done writing your answer down, hit unpause, because we're moving on to number 3, solve each equation. All right, the first one says 5 parentheses n minus 4 equals a negative 60. So I'm going to do some work here, and then I'm going to do some work elsewhere because there's not enough space here. Let's write this first one right here. 5 n minus 4 is equal to a negative 60. This can be done 2 ways. 5n minus 4s is kind of like saying, I wouldn't do it this way personally, so I wouldn't write this. It's kind of like saying 5 n's, and there's 5 minus 4s. There's 5 of each. 5 minus 4s would be a minus 20. I could do it like that. I guess it's not that big a deal. In fact, I could keep going if I really wanted to. But anytime I can see that this number and this number work well together, in other words, the left number can go into the right number evenly without leaving any remainder, I personally think I want to divide each side by 5. 5 divided by 5 is 1. 1n minus 4 is just an n minus 4. 60 divided by 5 is 12. A negative 60 divided by 5 is a negative 12. Now I just have something minus 4 equals a negative 12. Well, if something minus 4 equals something, if I take that something and add 4 to it, I would get the answer. If I add 4 to each side, minus 4 plus 4, that's cancels. That's 0. That gives me n, which is what I want. I want money. That's what I want. Who sings that song? No idea. So negative 12, if I'm negative 12 on the number line and I go 4 to the right, if I add 4 to it, that puts me at negative 8. And a negative 8 minus 4 is negative 12 times 5 would be a negative 60, so that works. Now the next one is a negative 3t plus a negative 8 is equal to 25. So first step is, just like the one above, I would get rid of the 10. By above, I mean that inequality. Or even the 28 students. The first thing we do is get rid of the 12 students that were in the van. Well, this is saying we need to get rid of this negative 8 plus negative 8. Getting rid of a negative 8 means we add 8. A minus 8 and a plus 8. If I do it to each side of the equation, it'll still balance. Remember, we got to balance. These are like hangers. Minus 8 and a plus 8. It's kind of like saying, how do I get rid of a negative 8 plus a negative 8 if I subtract a negative 8 minus a negative? Remember, it's just a plus in it. So 8, that's gone. Negative 8 and the 8 cancel, that's 0. So on this side, I still have a negative 3t. And this is 25 plus 8, which is 33. Now what? I have negative 3 times t, which means I got to divide each side by a negative 3. Negative 3 divided by negative 3 is just 1. 1t is written just like this, just t. We could write a 1 if we wanted to, but 1t is just a t. And now a 33 divided by a negative 3 is 11, except it's negative. 7p minus 8 equals a negative 22. 7p minus 8 equals a negative 22. I hope I wrote that right. How am I going to solve this one? Well, this says minus 8, so step 1 is to add 8 to each side. Minus 8 plus 8. Again, you're going to have to squeeze this in wherever and if you need to pause this and get some scratch paper, then that's fine too. Or write this in the margins, write this on the next page, write this on the previous page. Doesn't matter to me. Get scratch paper if you like. whatever you want. So a minus 8 and a plus 8, that's 0. And now I'm left with 7p on this side. That's equal to a negative 22 plus 8. If I were to go to the right, negative 22, negative 21 plus 8, that means I kind of do 22. If the signs are different, this is a negative, that's a positive. The signs are different, it says we subtract them. 22 minus 8, it's 14. And the bigger one, we keep the bigger one sign. This one's bigger because it's negative. Or no, because 22 is bigger, but it's negative. So our answer is going to be a negative 14. So negative 22 plus 8 is negative 14. Next step is 7 times what is a negative 14? Oh, well, I know it's 2 or negative 2. How do I get that? It's because I divide each side by 7. 7 divided by 7 is 1. 1p is what I want. 14 divided by 7 is 2. And a negative divided by positive is negative 2. The next one is 2/5 parentheses j plus 40 is a negative something. 2/5 j, oh, for crying out loud, j plus 40 equals a negative 4. 2/5 j plus 40 equals a negative 4. Why? 2/5 j plus 40 equals a negative 4. Why is that so hard for me to remember? All right, this one can be done a number of ways. Again, I could do 2/5 times j, which is just 2/5, and 2/5 of 40, which is doable. That would be 80/5. If I want to do that in 80/5, 5 goes into 80 evenly. 5 goes into 40 8 times. So that means 5 goes into 80 16 times. So I could do it that way. And then I have a fraction of 2/5 j that you should work with, though. Or I could go ahead and start off, and if remember in the previous problem, where was that other one? What did I do? Here, I divided each side by 5. This 5 goes into 60. I divided each side by 5. I'm going to do the same thing, except the number's not 5. Ignore 8th grade stuff. The number's 2/5. So I'm going to divide this side by 2/5. And I'm going to write it like this, just so this side by 2/5, so that you can see. Eventually I'm going to do keep, change, flip. 2/5 divided by 2/5 is 1. 1j plus 40 is just a j plus 40. And now I've got to keep, change, flip. And I'm left with a negative 4 times 5 over 1 times 2. There's an invisible 1 here that I could write. We multiply fractions. We do a numerator times a numerator, denominator times a denominator. I'm left with 20 over 2, or negative 20 over 2. And what is 20 divided by 2? It is 10, and the answer is negative. After all that, I have j plus, I shouldn't have circled that, j plus 40 equals a negative 10. So now what? Something plus 40 equals a negative 10. Well, something plus 40 equals that. If I take off 40 from that something, 40 minus 40 cancels. That's 0, and I'm left. If I take it off, remember I'm balancing it. If I take it off one side, I got to take it off the other. So a negative 10 minus 40. That's the same as a negative 10 plus a negative 40. The signs are the same. If the signs are the same, we add them and keep the sign. So 10 plus 40 is 50. And that's going to be negative. Or we can just visualize a number line. If I'm at negative 10, going further to the left, it's just going to make the negatives increase. So after all of that, I finally got j equals a negative 50. A lot going on right now. Last one, 4w. I can squeeze it in right here. equals a negative 6. Now, I could divide each side by 4, but guess what? Then I'm left with 6/4. Not a big deal. I guess I could still do that because I'm left with w plus 1 equals a negative 6/4. I guess that's not a big deal. Because either way, I might be left. Otherwise, I could do... And what am I going to do next? I'm going to have to subtract 1. I could subtract 1 from each side. Subtract 1 from this side. 6/4 minus 1. That's... Or negative 6/4 minus 1. 6/4 is 1 and 2/4. That's doable, but it's much easier when I noticed, as soon as I noticed that the 4 and the 6 didn't work well together, you're left with fractions, I was like, well, 4w plus 1s means I have 4 w's, and I have 4 1s, and I have 4. 4 1s is 4. Now I'm looking, I'm like, wait a second, I don't have to deal with any fractions yet. So, next step is, let's get rid of 4 from each side. 4 minus 4 is nothing. They're gone. I'm keeping this balance. A negative 6 minus 4 on the other side. They're the same sign, which means I add them and keep the sign. So it's negative. So now I have 4w equals 10. If 4w is equals 10, then 1w means 10 divided by 4. I'm dividing this side by 4, dividing this side by 4. 4 divided by 4 is 1, and I'm left with w equals, I could just say it is negative 10/4. That's fine. Simplifying this would be a negative 5 because 2 goes into 10 5 times. 2 can go into both 10 and 4. I could leave it like that, or I could say 4 goes into 10 twice with a remainder of 2. I could say it's 2 2/4, and it's negative. Or I could say, wait a second, that's 2 1/2. That's negative. All of these, this one's a correct answer. That's a correct answer. That's a correct answer. That's a correct answer. The very top one maybe is the best answer just because it's easy to see, but when all else fails, that first one wouldn't have hurt us. All right, number 4. Select all the inequalities that have the same graph as x is less than 4. Well, here's the graph of x is less than 4. Here's 4. And it's a hollow dot, not a solid one. Whoops. And the arrow goes that way. X is less than 4. There's the graph. Well, A is x is less than 2. That doesn't have the same graph. That starts at 2 and goes left. The next one says x plus 6 is less than 10. Well, I don't even know what x is less than there. So if I subtract 6 from each side, I'm left with x is less than 4. So guess what? That's the same thing. B is correct. How about 5x equals 20? Well, divide each side by 5, and I'm left with x is less than 4. So guess what? That works. Letter D says I need to add 2 to each side, and then I'm left with x is greater than 4. Trick question. That's almost correct, except we want x is less than 4. And then finally it says x is less than 8. That's not going to work. That would look different. That would start at 8 and go left. So it is B and C, and only B and C. And then finally a 200-pound person weighs 33 pounds on the moon. How much did this person's weight decrease? That's pretty straightforward. I'll let you figure that out. I do have a calculator somewhere. How much did it decrease? Well, if it was 200 and it went down to 33, if I subtract 33, 10 minus 3 is 7. Gotta borrow. That was a 10, it's now a 9. 100, it went down 167. By what percentage did the weight decrease? Great review question. It's been a while. But percent increase or decrease. First, to find the percentage change, you take the difference. This is going back to the stock market project when we had to find the percentage increase or decrease from the high or low. Take the difference and divide it by the original amount. How much did the person's weight decrease? The original amount was 200. So if I get out my calculator and I do 167 divided by 200. Okay, Google. What is 167 divided by 200?
167 divided by 200 is 0.835.
0.835. Thank you, Google. Okay, Google. Thank you. Not going to say you're welcome?
Not a problem.
Oh. Just thinking, didn't know what to say. All right, so, great Google. I already forgot that. What was it? Gosh darn it. What did I say? 0.835.
167 divided by 200 is 0.835.
Thank you. I found that already, though. 0.835. 0.835. That is not a percentage, though. That's a decimal. If I multiply that by 100, or multiplying by 100 means I move the decimal 2 to the right, that means there was an 83.5%. And since it's a decrease, we'll write a negative. And there we have it. And that makes sense. If we would have divided by the 33, that wouldn't have made sense. It went down 83.5%. And if I do remember, what do they say? Your weight on the moon is 1/6 of what it is on Earth. And that does make sense, because if it went down 83.5, it still means that you're 16.5%. That's roughly what 1/6 is. Maybe that's more accurate. Maybe 1/6 is. I think this way is more accurate. But that's all she wrote, folks. We're going to call it good. Have a good weekend. Keep it real. Keep it fake. Keep it Jake. Peace.